Hey everyone, ever catch yourself wondering, how computers actually think? I mean, they can do some pretty wild stuff.
It is pretty amazing.
Right.
Yeah.
Like, how do they do it?
Well, a lot of it boils down to something called arithmetic expressions.
Arithmetic expressions.
Yeah,
Okay, so that sounds kind of mathy.
it
Is
does.
that like what we're getting into today?
It is.
Okay.
It's really just how we use math to talk to computers. So,
So coding with numbers.
exactly. You got it.
Okay. So we're talking like basic math, right? Like plus, minus, times, divide.
Exactly. Those are our operators.
Okay.
The things that tell the computer what to do with the numbers.
Gotcha. So if the operators are like the actions, what about the numbers themselves? What do we call those?
Those are our literals,
Okay.
the actual values that we're working with.
So it's like we've got our ingredients and our instructions.
I like that analogy.
Right.
Yeah, because we're diving into this excerpt from 2.4.pdf today. And this doc, it's like our cookbook for understanding it all.
Okay, so 2.4.pdf, got it. We're cracking open the code cookbooks today. I'm into it.
And trust me, this is one recipe you'll want to know by heart because it's the foundation for so much of what makes software work.
Okay, you've piqued my interest, I gotta be honest. So we've got our operators, our literals. What else makes up this whole arithmetic expression thing?
Well, think of it like you wouldn't just throw ingredients together in a bowl randomly, right?
Unless you're making like a very chaotic salad.
True, some chefs love to experiment,
Right.
but even then there's a method to the madness.
Okay, fair enough.
Yeah, so just like a recipe gives you structure, arithmetic expressions provide the same for computers.
Structure meaning like the order of operations.
Exactly.
Okay.
It's all about making sure the computer knows exactly what to do in what sequence.
Okay, so no rogue computers just dumping all the code ingredients in at once.
Exactly.
Gotcha. So can we see an example of an expression in action? Like, how do I write one of these things?
Sure. Think about something like 2x1. That's an expression that tells the computer to add 1 to the value of x before multiplying by 2.
Okay, so those parentheses are important. It's not the same as just saying 2x1.
You're already picking up on a crucial point. The placement of those parentheses makes a big difference, and we'll dive into why that is in just a bit.
Okay, this is already making my brain do some interesting calculations. So these expressions, they're like the sentences of computer language, making sure things happen in the right order.
Precisely. And just like a misplaced comma can change the meaning of a sentence, the order of operations in an expression is critical for getting the right result.
Okay, so no pressure, but I'm already sensing that getting this order right is pretty important.
You could say that. It's like the difference between a perfectly frosted cake and a complete baking disaster.
Okay, you've definitely got my attention now. I am not here for baking disasters. So how do we make sure our code doesn't crumble? What are the rules of the computer kitchen?
Well, that's where things get really interesting. We're about to enter the world of precedence. And let me tell you, computers are sticklers for the rules.
Oh, this is going to be good.
Oh, yeah. Buckle up because things are about to get logical.
I'm so ready. Hit me with it. What is this precedence all about?
Okay, so imagine like a pecking order for math operations.
A pecking order? So like some operations are more important than others in the eyes of a computer?
Exactly.
Okay, I'm intrigued. Tell me more.
All right, so our source material actually has this super handy table 2.4.2, precedence rules for arithmetic operators.
Okay, table 2.4.2. Got it.
And it lays out the rules beautifully.
Lay it on me. What's at the top of the computer math hierarchy?
Parentheses, those are the VIPs.
Parentheses? Really?
Oh yeah, always first.
So if I see those little guys in an expression, I know that's where the action starts.
Exactly. It's like they're saying, hey, do this part first. It's important.
Okay, parentheses, got it. They're like the head chefs of the code kitchen. What's next in line?
After parentheses, we've got what's called unary minus.
Unary minus. Okay, that one sounds a little intimidating. What is that?
It's just a fancy way of saying like a minus sign stuck in front of a number.
So like negative numbers.
Exactly.
Okay, unary minus, got it.
Yep.
What about the classics? Addition, subtraction, multiplication, division. Where do those fall?
Okay, so multiplication and division, those guys are buddies. They share the same level of importance.
Okay,
And then you've got addition and subtraction bringing up the rear.
got it. So we've got parentheses, unary minus, multiplication and division, and then addition and subtraction. Is that right?
You nailed it.
Okay, cool. Because I was going to say my brain was about to short circuit if we added any more layers to this.
Don't worry, we'll keep it simple.
Okay, ish.
Yeah.
Okay, I like where your head's at.
But the cool part is, once you understand these rules, you can predict exactly how a computer will solve any arithmetic expression.
Okay, that is pretty cool. It's like having a superpower, being able to think like a computer.
Exactly. You're speaking my language now.
Okay, so speaking of thinking like a computer, let's go back to that example we talked about earlier. 2x1. Let's say x equals 3. How would a computer solve that?
Okay, so remember, parentheses are king,
Always.
right? So first we got to solve what's inside those parentheses, x1, which in this case is 3, 1.
Okay, so that's 4.
Exactly. And then we multiply that 4 by 2 outside the parentheses.
Which gives us 8.
See? You're a natural.
This is kind of fun, I'm not going to lie.
Right.
It's like solving a little puzzle.
It totally is.
Yeah.
And just like with puzzles, getting the order right is everything.
That's true, because if we had just gone from left to right in that example, we would have gotten 7, not 8.
Exactly. And that's why understanding precedence is so important.
Okay, point taken. I'd much rather get an A in computer math than accidentally launch myself into space because I forgot about parentheses.
Yeah, I think we can both agree that's the preferable outcome.
Definitely. So let's crank up the difficulty a notch. What about that animation content section from our source material? They've got that expression, y equals 3, x plus 10w.
Oh, yeah, that's a good one. And they even give us values for x and w. X is 4 and w 2.
Okay, so even more pieces to our puzzle. Let's break it down. Where do we even begin?
All right, so back to our VIPs, the parentheses.
Right, always the first stop.
Inside we've got x10w, and since we know w is 2, we can tackle that division first, 10, 2.
Which gives us 5. Okay, so now our expression inside the parentheses is x5.
Looking good. And since x is 4, we can simplify that to 4 plus 5.
Which is 9. So now we're left with 3, 9, because remember those parentheses were telling us to solve everything inside them first.
You've got it. And 3 times 9, that gives us 27.
Oh.
So 5 is 27.
We did it! We officially think like computers.
I knew you had it in you.
I'm starting to feel like a coding rock star over here. But hold on, before I get too carried away, you mentioned earlier that messing up this order of operations is a common coding error.
No, it happens all the time, even to the best of us.
Okay, so let's talk about those potential pitfalls for a second. I want to make sure I'm not accidentally creating any code catastrophes over here.
That's a good instinct, because even a small mistake can snowball into a big problem.
Okay, I'm listening. Give me an example of what not to do.
All right, let's go back to that earlier example, 5x1. Remember how we talked about the importance of those parentheses?
Yes, vaguely. I mean, it was like 5 minutes ago, but yeah, those parentheses were pretty important.
Right. Well, imagine we forgot them completely.
Oh no, this doesn't sound good.
And instead, we just wrote 5x1.
Okay, so no parentheses, just going straight across.
Exactly.
What happens then?
Well, the computer's going to follow those precedence rules like it's nobody's business.
Okay, so which operation is it going to prioritize in that case?
Multiplication.
Right.
Remember, it ranks higher than addition in our computer math pecking order.
Right. Parentheses unary minus multiplication and division, then addition and subtraction. Got it. I think I'm starting to memorize these.
You're getting there.
Okay, so back to our example, 5x1, with x being 2. What's the computer going to do?
It's going to see that 5, 2 first and calculate that, giving us 10.
Okay, and then
And then it'll add the 1, giving us a final answer of 11.
okay, so not 11. Then what would it have been if we'd kept those parentheses in there?
Ah, good catch. If we wanted to add x and 1 before multiplying, we'd need those parentheses to tell the computer, hey, this part first.
So it's all about clarity.
Exactly. Parentheses are like the punctuation marks of code. They help us write clear and unambiguous instructions.
Okay, I like that analogy. I'm all about clear communication, especially when we're talking computers, because they're kind of notorious for being a little bit literal.
Tell me about it. One misplaced symbol and your whole program could go haywire.
Okay, so parentheses, they're our friends. They save lives, potentially.
You could say that. They definitely save programmers a lot of headaches.
Good to know. So I'm starting to see how these expressions work, how the order of operations is crucial. But can we talk about where this actually shows up in the real world? Like, does my phone secretly have a whiteboard full of equations taped to the back?
Well, maybe not a whiteboard, but you'd be surprised how often these concepts pop up in everyday tech.
Okay, like where? Give me an example.
Remember that calorie expenditure example from our source material?
Oh, yeah, the one with the formulas for calculating calories burned during exercise.
Exactly. That's a perfect illustration.
Yeah.
A fitness tracker. That's basically a walking, talking arithmetic expression machine.
Whoa, really? I never thought of it like that.
Oh, yeah. It's taking inputs like your heart rate, your age, your weight, the type of exercise you're doing,
Okay.
and plugging them into those formulas. And guess what? Those formulas are just cleverly disguised arithmetic expressions.
Mind blown. So all this time I've been working out, my fitness tracker has been secretly doing advanced math.
Exactly. And without those precise calculations, you might end up with totally inaccurate calorie counts.
Okay, that makes sense. So those calories man and calories woman lines in the code, that's where the magic happens.
Precisely. It's
Or-
all about connecting those variables and values using our trusty operators, just like we've been talking about.
Wow. I'm starting to see the world in a whole new light. Like everything is just numbers and equations working behind the scenes.
That's what's so cool about this stuff. Once you start to see the patterns, you realize just how fundamental these concepts are.
It's like the Matrix, but for math.
Exactly.
This is why I love these deep dives. We always end up in the most fascinating places.
Me too. It's amazing how much we can unpack from just one little excerpt of source material.
Totally. So as we wrap up our arithmetic adventure, any final words of wisdom for our listeners on why understanding these concepts matters?
Well, to put it simply, mastering the order of operations, those precedence rules, it's like having the secret code to unlock clear, accurate, and predictable code.
Okay, so it's not just about passing our computer math exams, it's about writing better code overall.
Exactly. A misplaced parenthesis might seem like a small error, but it can have a huge impact on the final result. It's like that old saying, for want of a nail.
The shoe was lost, the horse was lost, the battle was lost.
Right, I know that one.
Exactly. So to all our listeners out there, embrace those parentheses, make friends with precedence, and never underestimate the power of a well-crafted arithmetic expression. I love it. And for those of you who want to put your newfound knowledge to the test, don't forget to check out question 6 in our source material. It's all about calculating something called two-it count. See if you can use what we've learned today to crack the code.
It's a fun one. And on that note, I think it's time for us to sign off.
Until next time, happy coding, everyone.
And happy calculating.